In this video, we are going to be taking notes on simplifying, multiplying, and dividing rationals. Remember, a rational is a ratio or fraction. In problem number 1, we're supposed to simplify the expression and state the excluded values. Over here on the right, I've given you some steps. The first step is to factor the top and the bottom. Sometimes our factoring will be with quadratics and the like, or sometimes we'll just have a single term on the top and bottom like we do on this one. So I'm going to start out and I'm going to factor the top. I'm factoring 85 x to the 6 y to the 5th. If it's one term, you may want to list out the numbers. 85 is 5 times 17. And then x, I've got 1, 2, 3, 4, 5, 6 x's. I've got 1, 2, 3, 4, 5 y's. On the bottom, I have 20. It's negative. So I'm going to list my negatives separately. And then 20, if I did a prime factorization, is 2 times 2 times 5. X to the 4th means I have 4 x's, and y to the 9th is 9 y's. Hopefully in the future we won't have to write out every x and y like this. We'll just use our rules of exponents as we go. But that's where we are. So step 1, factor the top and bottom. We've done that. Step 2 is to set each factor on the bottom equal to 0 and solve to find the excluded values. You need to know what this means, excluded values. Excluded values are things that we're not allowed to have happen in the fraction. Why would we not allowed to have something happen in a fraction? Well, in math, we're not allowed to divide by 0. No divide by 0. So the bottom of our fraction can't equal 0. Looking at each term individually, each of the numbers, that can never equal 0. But what we would have for our excluded values, I'll write them separately. Excluded values, x could not be equal to 0, and y could not be equal to 0, because both of those would create division by 0 on the bottom of our fraction. The next step is to reduce any factors that are the same on the top and the bottom. So with the number, I have 5 can go into both the top and the bottom, so I could reduce that just like I would have in elementary school, or I could have listed out the factors and reduced it this way. I take a 5 out of each. I've got 4 x's on the bottom, and I've got 6 on the top. So I can get rid of 4 from the top and 4 from the bottom, which would leave me with a total of these 2 left on the top, x squared. I also could have done that by subtracting my exponents and doing x to the 6th divided by x to the 4th. Subtract the exponents is x squared. With the y's, I've got 5 y's on the top. There's more on the bottom, so I can get rid of 5 down there, and I'll still have 4 left on the bottom when I do that. So my final answer here, the negative remains. I can either write the negative out front on top or on the bottom, it doesn't matter. On the top I have a 17, and I have 2 x's, so x squared. On the bottom I have 2 times 2, which is 4, and I have 4 y's, so I have y to the 4th. I can write my fraction like this, or as I mentioned, I could put the negative 17 on the top if I wanted to. Sorry, that's negative 17. X squared over 4y to the 4th, or I could leave the negative on the bottom and write this as 17 over negative 4y to the 4th. It doesn't matter which way you write it, but you need to realize if you have a multiple choice, it could be any of those. They're all the same thing. What's not allowed is putting the negative on both the top and the bottom. That would be against the rules. Okay, so step 3, reduce the factors, and we're done. Okay, so let's scroll down a little here and we'll put up example number 2. Erase my checks, and let's start out with our steps. We're going to begin by factoring the top and the bottom. On this one, when I look to factor, I can see I have a GCF on the top. 3x squared goes into both of those. So I can take the 3x squared out. If I did that, it will leave me with 7 and minus x. On the bottom, I can factor. If I factor x squared minus 49, that's a difference of squares. It factors into x plus 7 times x minus 7. So now I've started out, I've done my beginning factoring. Next step is to set each factor of the bottom equal to 0 and solve to find the excluded values. So for this one, my excluded would be where the bottom is equal to 0. So if I set each factor equal to 0, x plus 7 cannot equal 0, so x cannot equal negative 7, and x minus 7 cannot equal 0, so x cannot equal positive 7. Those are my excluded values. X is not allowed to equal those numbers. All right, I also want to reduce my fraction at this point in time, and I'm looking and I'm not seeing anything in common, but one of the kinds of factoring that we haven't really addressed a lot is like this. We have a 7 minus x on the top and an x minus 7 on the bottom. Order matters with subtraction. However, I could have in that first step up at the top, if I had taken out a negative instead, so if I took out a negative 3x squared, then my 7 would have switched to a negative and my x would have switched to a positive. The reason I might like to factor it like that is because negative 7 plus x is the same thing as x minus 7. That's showing us that we can do some reducing. And I could take this factor and reduce them out, and what I'd have left in the end is the negative 3x squared on the top and the x plus 7 on the bottom. I have a tendency to leave that in parentheses. You wouldn't have to, and if it were multiple choice, it might not be left that way. All right, on number 3, I've got some standard trinomial factoring where I've got a quadratic on the top. So on the top, I'm looking for what two things multiply to 25, x squared, and add to 10. So those two things are going to be 5x and 5x. So I can take out my GCF, finish up my factoring, and the top factors into x plus 5 times x plus 5. I know I could write this as x plus 5 squared. I usually don't because when I'm reducing, I want to see if I'm going to lose one factor or both of them. So on the bottom here, I'm looking for what two things multiply to 20x squared and add to 9. That would be 4x and 5x. So the GCF there is x, and then I've got an x plus 4 and a plus 5. My factoring checks out. So my two factors are x plus 4 and x plus 5. So I've done the first step of factoring the top and the bottom. At this point, remember, I also want to state my excluded values. So what's excluded here are anywhere the bottom would equal 0. So I have x plus 4 cannot equal 0. So x cannot equal negative 4. And x plus 5 cannot equal 0. So x cannot equal negative 5. We won't always write these down, but sometimes we ask you for them, sometimes we don't. You'll just have to read the directions. It'll also come up later when we do some graphing. Okay, next thing I'm going to do is I'm going to do some reducing. So what can I reduce? I've got an x plus 5 on the top and on the bottom, so I can reduce that. And my final answer, what I have left, I have an x plus 5 on top. I have an x plus 4 on the bottom. So there's my answer. Okay, so next we're going to move on to multiplying each expression. Remember, when we multiply two fractions, we multiply straight across the top and straight across the bottom, just like we did with plain old number fractions. We're going to start all of our factoring problems the same, all these rationals, factor the top and the bottom. The difference is, in these problems, we might have the opportunity for more factorings. So my first one is to factor the 2m squared. Let's put that in a box. 2m squared plus 3. And now I'm trying to figure out what two things multiply to 6m squared, and they have to add to the middle there, which was 7m. So that is 6m and 1m. The GCF up the top is 2m. So I have an m up here, a plus 3. I'd have a plus 1. Double check, that factor's great. So my two factors are m plus 3 and 2m plus 1. Next, I'm going to factor the bottom of that one, which was already in nice factored form. That's m minus 4. So that gives us a little break there. On the top, I've got to factor m squared minus 16. That's a difference of squares. It has two terms. We should recognize that factors into m plus 4, m minus 4. And on the bottom, we're factoring m squared plus 8m plus 15. So I'm going to do another set of boxes because this is a typical 3-term. So I'm looking for what multiplies to 15m squared and adds to 8m. So that's going to be 3m's and 5m's. GCFs. And double check, 5 times 3 is 15. Looks good. So my two factors are m plus 3 and m plus 5. So this step is done. Factor the top and bottoms. Next step is to find the excluded values. So the only difference here is now I have two fractions. So for this one, my excluded values is going to have more than one fraction to deal with. I have m minus 4 cannot equal 0, so m cannot equal 4. I have m plus 3 cannot equal 0, so m cannot equal negative 3. I have m plus 5 cannot equal 0, so m cannot equal negative 5. And that one has 3 excluded values because it has 3 factors on the bottom. Okay, so now I'm ready to get to the multiplication part. Rather than multiply all of this stuff together, it's easier to go through and reduce any factors that we can from the top and the bottom. So, because of multiplication, everything is now on the top together and everything is on the bottom together. So I can take an m plus 3 from the top and bottom of either fraction. Do I have anything else in common? I've got a 2m plus 1 on top. I don't have any of them on bottom. I have an m plus 4 on top and none of them on the bottom. But I also have an m minus 4 on the top and I have an m minus 4 on the bottom, so I can reduce those out as well. So I've reduced what I could. Now I'm left for step number 4, which says to rewrite, leaving the factors on top and the factors on the bottom on the bottom. So that's my final step here. In my answer, I have 2m plus 1 on top. I have m plus 4 on top, and all I have left on the bottom is m plus 5. On the top, I would have to leave the parentheses. On the bottom, I don't have to, but those are my factors. So go ahead and turn the page over and pause the video while you do problem number 5. Remember to state the excluded values and factor everything, and then you can unpause the video and see how you did. So for this one, I factored the top and the bottom of each fraction. To find my excluded values, I set the bottom equal to 0, and for my excluded values here, I got a could not be equal to -1, +1, 0, and -2, because that's where all the denominators were 0. Then I had to go back and do some reducing. So I looked for factors in common on the top and bottom, and I could get rid of my a plus 2 on the top and bottom, and I could get rid of my a plus 1 on the top and bottom. So my final answer, I had a minus 2 left on the top, and a times the quantity a minus 1 left on the bottom, and I'm done. All right, one more type of problem to do, and that is division. On number 6 on, we're going to divide each expression and state the excluded values. So for this one, my first step, just like all the other ones, I don't know what craziness happened there, sorry, is to factor everything. If I look at this problem, it's already primarily written in factored form. The only thing that I don't like so much is this factor on the top. I would probably take a negative out of that so that it could be called -4 plus x, which means that that top factor is the opposite of x minus 4. So when I'm doing my factoring and rewriting it, I would call this top negative of x minus 4. And then the factors on the bottom look pretty good to me. 3x plus 2 and x minus 2. Remember, this was a division problem. On the top here I had 5, x minus 4. On the bottom, x minus 2 and 7y minus 5. Okay. So that's my first step, to make sure I've factored everything. Remember that division is where we multiply by the reciprocal of the second one. me jump over here and do a quick division problem. If I had 1/2 divided by 3/4, I would change that to 1/2 times 4/3, which is the reciprocal of 3/4. So I flip the second fraction. Then I would reduce what I could. 2 goes into that once, 2 goes into that twice. I multiply straight across the top and get 2, straight across the bottom and get 3. And that's how I divided two fractions when I was in elementary school. We're going to go by the same concept right here. So our first fraction we're not going to touch. I have the opposite of x minus 4 all over 3x plus 2 times x minus 2. Then I'm going to flip the second one. So in the second one, the 5 and the x minus 4 are moving down to the bottom, and the x minus 2 and the 7y minus 5 are moving up to the top. All right. So I wrote down the steps there that I did. On number 2, I changed the division to multiplication by flipping the second fraction. And for step number 3, I reduced and multiplied. So that's what I have to do right now. I'm looking for things we have in common on the top and on the bottom. So I have an x minus 4 on the top and bottom. I can reduce that one out. And I have an x minus 2 on the top and the bottom. I can reduce that one out. So what do I have left in the end? I have a negative left on top. I have a 7y minus 5. And on the bottom, I have a 3x plus 2. And I have a 5. I would usually write the 5 out in front, so I might want to scoot that over. It doesn't really matter how much space you give it or which order you write the factors in, but typically we put the plain monomial factors before the ones with addition and subtraction in them. Okay, so now I've reduced and multiplied. The only thing I didn't address with this is up in the directions here, they asked me to state the excluded values, which I didn't do anything about that in this problem. And with division, we have something a little different that happens. So for the excluded values, just like always, we had to set the bottom equal to 0. Oops, sorry, I was trying to highlight. We had to set the bottom equal to 0 and tell what couldn't exist. In the original problem, we had these things on the bottom, but once we flipped, we also had these things on the bottom. So just make sure that we've set every time something was in the bottom equal to 0. So my excluded values for this one, for my original problem, if 3x plus 2 cannot equal 0, then I'm going to move the 2 over and I'm going to divide by 3. X can't be negative 2/3. I had x minus 2 could not equal 0, so x could not be equal to positive 2. I had another x minus 2, so I don't need to write that again. I have 7y minus 5 cannot be equal to 0, so I move my 5 over and then I divide by 7, and y can't be equal to 5/7. And then in the last one, I had 5 can't be 0, but that's never going to happen, so I don't need to worry about it. And I have an x minus 4 that cannot be equal to 0 from the top, which gives me x cannot be equal to 4. So this has 4 excluded values. In problem number 7, it's another division problem. It's just written differently. We know a fraction is division. This is called a complex fraction. All this really means is to take the top of the problem and then divide it by the bottom of the problem. So I could have written this as a squared plus 2a minus 15 over a squared minus 16 divided by a plus 1 over 3a minus 12. So why don't you pause the video while you try this problem, and then we'll pause the video and do number 8 as well, and hopefully we get the hang of this. All right, so on number 7, I started out, I factored each of the problems. That made me have excluded values at a equals negative 4 from that one, a equals positive 4 from that one, a equals negative 1 from that one, and going back up to the original one, this one used to be on the bottom, so that was another a equals 4. Then I went through to reduce what I had in common. I had an a minus 4 on both the top and the bottom that I could reduce out. I had nothing else that they had in common, So then I just put everything together, my 3 terms on top and my 2 factors on the bottom. And there's my answer. Go ahead and pause the video if you haven't done number 8 yet. If you have, let's check that one. Okay, go ahead and check this one. The excluded values on this one were a little bit nasty for our expression over here, the 5 plus 3x cubed. If we set that equal to 0 and solve it, I just did the cubed root of both sides, and we wound up with x not being equal to negative the cubed root of 5/3, which we could simplify to negative the cubed root of 45 over 3 if I rationalize the denominator. We wouldn't be that picky with you. Just realize that the bottom can't equal 0. So go ahead and see what questions you have when you come into class tomorrow, and we'll do some more practice.